Good day, ladies and gentlemen. This is Sarel van Grinnen, aka Mr. VG, and this is video 2 of the winter school looking at equations and inequalities, and we are proudly supported by Investec. Now, what's going to happen in this video specifically is we are carrying on with working through the November 2021 exam paper written by the Department of Basic Education students, and I'm going to work through question 1.2 and 1.3. But please, again, I encourage you to not just look and go, oh, so I know how to do this, I'm going to skip to the next video. I encourage you, lean in, watch the video, because I'm not just going to go and work through the video, work through examples or through the questions. I'm going to show you my thinking and how you can apply it for your own future. So in this video, we are specifically going to look at these two questions. Question 1.2 is a very stock standard, straightforward, simultaneous equation, okay? Solving two equations simultaneously, but 1.3 is an absolute beaut of a question. A beautiful, beautiful question. So before you watch the rest of the video, try these sums yourself, and then you come and watch the rest. Let's look at question 1.2. Solve simultaneously for x and y. I encourage you, please don't go into autopilot, where you just write and write and write and write and write. Think about what you're writing. Make sure that you can do this. You need to score marks, ladies and gents. If I look at the matric results in South Africa, where the average is in the 30s, we need to score marks. So what is the basic steps of simultaneous equations? There are 4 basic steps: are isolate, substitute, solve, and then substitute again. Those are my 4 basic steps. And I've seen many of them. I know there are also simultaneous equations where you use equate left and right or equate y's. There's also elimination, which we are going to look at, but I very seldomly see that in question 1. I usually see that in other forms of the question papers, other questions. So let's talk about isolate. Pick an x or a y for you to isolate. I'm going to isolate x by taking the 3 over, transposing it. So x becomes 2y minus 3. Substitute this x into the other equation. And now I am solving for y. So I'm done with substitution. Now I'm busy solving. So when I look at this, I am going to see, I don't know what kind of an equation it is here. So let's first remove all the brackets. Then I see a quadratic equation forming. So I need to get equal to 0. Transposing, getting it into a simplest form. Now to make life easy, I'm going to divide by 2 on both sides. So sorry for moving over to another slide, but this is just where we ended off. I don't have enough space on one slide to finish the sum off, so I'm just going to now divide by 2 on both sides, factorize, and then I've got my solutions for y. Please don't stop. Remember, simultaneous equations means there's an x and a y to solve. You don't want to lose the last mark or 2 by not solving the other variable. So I'm going to substitute back. I love to pick the one where x is already on its own. So x is equal to -2. So this means I actually have a set of coordinates. My set of coordinates are a half comma, negative 2. No, no, no. Don't fall into the trap I just fell in. Ha! X comes first, and then you've got y. Even though you didn't solve x first, it's still first in my equation. Let's go to the second one. X is negative 1. So how does my set of coordinates look? Negative 1, comma 1. Actually, ladies and gents, this is where two graphs are equal to each other at those two sets of coordinates. Interesting, eh? Interesting. Let's look at question 1.3, which in this question 1 was the only question where I really had to dig deep and really had to think about it. So they do love to ask you this. For those of you that are getting your 40s and 50s or below, I encourage you to not get stuck on a question like this that's only worth 4 marks. If you don't know what to do, spend 4 minutes. Look at this, 4 minutes on this question and move on with your life. Come back to it later on and you can try again. Do not spend 10 or 15 minutes on the sum and then forget to do other sums. Please, you don't want to do that. Please, 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 please. But if you are an 80 or 90% and your maths, you like it, spend some time on this one. But for you as well, do not let a sum like this freak you out that you hit blank for the rest of the question paper. Identify it as a tough question and don't spend too much time on it. So let's look at how I analyze this question. Well, first of all, it kind of reminds me of my quadratic formula. I see it because there's a root in it, there's squares, etc., etc. I don't know whether I'm going to use it, but let's just say that I see it. Okay, I recognize it. And I'm awesome for seeing it. Just having fun. They say that M, N, and P are positive real numbers. That's important, the positive part. We'll talk about it later on. Also, it says M, N, and P form a geometric sequence. Now, I said series, but actually it's a sequence. Why? Because I am not adding them together. Okay? You see the fine little nuances, the fine little things that I'm looking out for. And I sometimes make mistakes, and that's fine. But then I just correct it. So I'll look at what does it mean if a series or a sequence is geometric. We'll look at that. But now the question is, prove that x is a non-real number. Non-real. What does non-real mean? It means there's a negative under my square root. Now that's not written mathematically correct at all. But that is what we need to prove, that there's a negative under my square root. Okay? Be careful of that. Because if you don't really know what you need to prove, you are not going to know where to go with this question. So I'm going to start by looking at a geometric sequence. Now, a geometric sequence, sorry for writing over myself there, okay? Let me just move this a little bit to the right, okay? Now I moved everything. Let me rather erase and write it out proper for you to see. Whenever we talk about a geometric sequence, I love to remember T2 over T1 must be equal to T3 over T2, which tells me that N over M must be equal to P over N. Now, I don't like to work with fractions, so I multiply by my LCD straight through. So in other words, N squared must be equal to M times by P. Again, just let me make sure that you understand the M and that M cancels out, they divide away. That N and that N divides away. So on the left, I'm left with N squared equal to MP. Some of you like to say cross multiply, but you get exactly the same answer. Now, I'm not sure where I need to go with this at this moment, but I know that I need to get back to the original equation, the roots of the original equation, the solutions of the equation. I need to go back there. Now, I see something. I hope you see it as well. That I actually have an expression for N squared. That N squared is actually M times P. So I substitute that into N squared, M times by P. And let's see where we go. If I now simplify under the square root, I get negative 3 MP. Now that is interesting. 1 MP minus 4 MP is negative 3 MP. Why is that interesting? Because M and P are positive numbers. So if I say a negative 3 times by a positive times by another positive, what does that give me? A positive or a negative? It gives me a negative. So therefore, x is actually an expression with a negative under my square root. What does that tell me about x? That tells me that x is non-real because I'm sitting with a negative under the square root. Wow, that is interesting. Very interesting. There is another way that we could have looked at this. And I'm seeing this as I'm going through the question with you. This is the beautiful thing for me about maths, is I like to look at different options. What if, ladies and gentlemen, what if we looked at, instead of replacing MP or N squared, I replace the MP with N squared. Where does that come from, sir? Well, remember that MP is N squared. Then, in my square root, I'm actually sitting with N squared minus 4N squared, which means this is negative 3N squared. Oh, I like this. I like the look of this. Because if I look at N squared, that answer is always greater or equal to 0. Why? Because N is a positive, real number. Now, if I multiply this positive by a negative, well, that answer is smaller or equal to 0. But why can't it actually be equal to 0? Because they say the numbers are positive. So in other words, N can't be 0. So that means that. Now, I'm just going to write it here. Remember, N is positive. Which still leads me to exactly the same conclusion, that I am sitting with a negative under the root, which gives me a non-real solution. This is beautiful. Two different ways of answering the same question. Ladies and gents, please make sure, especially if you are an 80 or 90%, even your 60s and 70s, that you can get different options of looking at the same thing. You might not need to use it now, but maybe in a test going forward, you are going to need that way of thinking. This is lovely. I love maths. Oh man, I get so excited. This is Sarah van Greenen signing out. Please tune into our next video, which is going to be about sequences and series, where I'm going to start off by looking at the different formulas you've got on the formula sheet. So have a beautiful, wonderful rest of your day. Go and be awesome. And thank you for tuning in. Looking forward to our next video together. Keep well. Cheers.